we're starting the next unit, which is Unit 5 over exponential functions and logarithmic functions. The first two learning targets are really easy, though. They're just exponent rules. You guys have seen them about 1,000 times. But we're going to go through them to make sure everyone's on the same page. Okay? So here are all the rules that you have seen before a million times. If you have a base to the first power, then it's just whatever that base is. We all know that. No big deal. If you have a base as some exponent, that just means you're multiplying that value by itself that many times. That's what an exponent is. We all know that too. If you have a base to the 0 power, that's equal to 1. Does everyone know why that works? If not, I can explain it to you with the rule below. And then if you have a negative exponent, we won't have any negative exponents in our answers here. So if you have a negative exponent, you have a reciprocal, right? You've seen those before. You've also seen all of these properties. If you're multiplying two things with the same base, then you add the exponents. Don't get tripped up on that. People still get confused from time to time. They just get lost in what they're doing. They just multiply them. Make sure you're adding them. If you have an exponent on the outside of the parentheses, you have to technically distribute that exponent, right? Make sure you do that. Same thing. Make sure you distribute that exponent. If there's more than one term inside the parentheses, make sure you distribute the exponent. The biggest mistake I see is when you have something like 4x to the second to the third power. There's a lot of people that will forget to distribute the third power to the 4 to the first power, right? You have 4 to the third, and you have x to the sixth. A lot of people forget the 4 to the third part. Don't forget that coefficients still count on what you're doing, okay? And then when you have a quotient, you subtract the exponent. That's why b to the 0 power works. If you have x to the 6th power over x to the 6th power, you're supposed to subtract the exponents, right? Be x to the 0 power. Well, x to the 6th over x to the 6th, that's something divided by itself. So that's just 1. That's why something to the 0 power is 1. That's why that works. Make sure you know that. It's not just some random rule that people made up one day. You guys have also seen rules involving rational exponents. Okay? So if you have a fractional exponent or a rational exponent, you can rewrite that using a root or vice versa. Just remember the denominator is the root number and the numerator is the exponent. All right? So again, if you have x to the 4/5, then that's the 5th root of x to the 4th power. So just remember the bottom number is your root number, the top number is your exponent. Have we seen all these before? Are we doing okay? In Learning Target 1, you can do all of these in your calculator. I am quite aware of that. We're just evaluating expressions. But I want us to make sure we practice with the rules to think about how we could have gotten to that number. Okay? So on your quiz, I might ask you just to rewrite it. Because I know you can do it in your calculator. I know you can just type that in. It's not a big deal. Okay? So for the first one, you have 5 to the negative 4th power. How would I rewrite that? 1 over 5 to the 4th power. And then we could figure that out. So 5 to the 4th power is 625, right? Not the 44th. Yeah, 625. You would leave that in fraction form. I don't need a decimal. On the next one, you have two approaches. Since you have a negative exponent, you can take the reciprocal first to this positive second power, or you can distribute the negative exponent and then take the reciprocal. Both of them get you the same place in the same amount of steps. All right? So if you want to take the reciprocal first, you have 16 over 9 to the second power. That's what negative exponents do. They give you reciprocals. Or you could distribute the negative second power. Bless you. Over here to distribute, we get 16 to the second over 9 to the second. And over here, we would have to go ahead and now flip it because we have negative exponents and we have positive ones. Right, same amount of steps, doesn't matter, right? And so we have 16 squared, which is Not remember. 256 over 81. Same thing over here, 256 over 81. Questions about that? For the next one, you have 216 to the 1/3 power. So we're going to rewrite that without the fractional exponent. How would we rewrite it as a root? The third root of 216. If you don't know where the third root is in your calculator, if you go to math, it's number 4. If you want to do any root, you type in the number first, and then you type in number 5, where it says x root. So you have 6. What do you know about radicals? We're multiplying 2 radicals here. What do you know about radicals with the same root? What can we do with these before we do anything with exponents? We can multiply, right? That would be the easiest thing to do here. We have the square root of 27 times the square root of 3. That's the same thing as the square root of 27 times 3, which is the square root of 81. And what's the square root of 81? 9. So you can do it that way. You could rewrite 81 to the 1/2 power. We'll go into a more detailed how to rewrite that when we do learning target 3 tomorrow. Because we're going to be solving some equations. We have to rewrite some things. Questions about that? On the last one, you have 32 to the 3/5 power, so how would you rewrite that one? The 5th root of 32 to the 3rd power. The 5th root of 32 is 2. And 2 to the 3rd power is 8. Again, I know you could just type all of those straight into your calculator. I get it. Just making you think about your exponent rules before you start getting into anything else. Any questions on any of those? The rest of them today we're doing learning target 2. We're just simplifying, which means we can't actually get a numerical answer at the end. We're still going to have it with variables. All right, on learning target 2, we're going to simplify. And when we simplify, we don't want any negative exponents, and we don't want any roots left. So your answers will be all with exponents, and if they have to be fractions, that's fine. Okay? So, on the first one, we're going to focus on this part first, just because of the order operations. We need to go ahead and do some extra things. So, what am I going to get if I simplify that part? Or just the first step of simplifying that part? Excellent. You multiply the 3 by all the exponents inside the parentheses. Again, don't forget about the 3 to the 3rd. That's the biggest mistake I'll see on the quiz. I can guarantee it right now. And then I have times 3a to the 5th. So we're multiplying 2 terms together, so what happens to the exponent? Add them, and for the same basis, we have 3 to the what power? And a to the what power? -1. 3 to the 4th power is 81. And we have a to the negative first. We don't want any negative exponents, so it's 81 over a. Questions about that one? On the next one, we have the same root number. We have 2 square roots. We just did this with a problem on the learning target 1. We did the square root of 27 with the square root of 3, and what did we do? We just multiplied everything underneath the square root, right? Same thing here. That's going to be the first step, unless you want to start with fractions. You do it that way too. And what I'm showing you is not the only way to approach these. So if we're going to multiply the 2 square roots, I get m to the what and n to the what underneath the parentheses, underneath the root. 7 and 7. Because you m to the third and m to the fourth, you add the exponent. Same thing with the ends. But we're rewriting these without any roots. So that means I have m to the 7th, n to the 7th, to the 1/2 power. Okay? That's what square root is, the 1/2 power. And so I just need to multiply the 1/2 by each 7 to get this in its final form. M to the 7/2 and n to the 7/2. 7/2. Again, we're writing them all without negative exponents, without roots. Questions about that one? On the next one, you have to the 1/2 power. So I would multiply all of your exponents on the inside of the parentheses by the 1/2 power. You can simplify as you go, or you can write it out. I'm going to write it out so no one gets lost. But you can simplify as you go, because some of those reduce. But you get 2 to the 1/2 power, x to the 4/2 power, and y to the 8/2 power, just by multiplying straight across. So you have 2 to the 1/2, x to the 2nd, y to the 4th. Questions about that one? Again, you guys have seen exponent rules before. To the 1/2. That would be the square root of 2. And we're just writing them without roots. Any questions on those 3 examples? We're getting close to being done for today. All right. On these 2, we're expressing using rational exponents. That means we don't want a root. No roots allowed. We have to have fractional exponents. Okay? So, here you have the square root. What's the square root of 169? 13. So you can either rewrite it as 169 to the 1/2 and then get to 13, or you can just get it to 13 from the beginning. Either or, you have to have 13, because we're simplifying. And then we have x to the what power? 5/2, right? Your exponent is the numerator, and the root number is your denominator. Best you can do. Questions about that one? Same thing for the next one. You have the 4th root. So that's going to be the denominator for all of your rational exponents. Again, you can simplify as you go, or you can do it in 2 steps. I'm just going to do it in 2 steps to make sure everyone's with me. So we have a to the 2/4, b to the 3/4, c to the 4/4, and d to the 5/4. Some of those reduce and some of them don't. So you have a to the 1/2, b to the 3/4, c to the 1st, and d to the 5/4. Does that one make sense? We're just rewriting using fractional exponents instead of a root. Then the last 2 do the opposite. They ask you to use a radical instead of a fraction. Okay? So they want a radical. That means 1 radical. That means you have to have the same root number for all of them, which means every single one has to have the same denominator. So for the first example, already done for you. Second one, you have to do some extra work. Okay? So for the first one, you know all of these have the same denominator, so you're going to have the 4th root of 6. So the first power is just 6. B to the 3rd, C. Right? Not a big deal. It's already done for you. On the second one, you do not have the same root number. You have 15 to the 1st, x to the 1/3, and y to the 1/5. So how can I do this, manipulate this to have the same denominator? Right, you'll have to have a denominator of 15, just like if you're doing fractions and you wanted the least common denominator, right? Least common denominator is 15. That's the lowest you can get. So if I rewrite this, if I want 1 over 1 to have a denominator of 15, you're multiplying it by 15 over 15. I'm going to write this with exponents first. If I want 1/3 to have the denominator of 15, I need to multiply by 5 over 5. So x to the 5 over 15. And if I want to multiply 1/5 to have a denominator of 15, I multiply by 3 over 3. You have 3 over 15. Now it looks just like the example we just did. Everything has the same denominator. We can use the same root. So we have the 15th root of 15 to the 15th power, x to the 5th, y to the 3rd. Questions?